In this presentation, we'll take a look on how to determine the KLA through the data analysis. The experimental determination of KLA can be done through 4 methods, which are static gassing out, dynamic gassing out, oxygen balance method, and sulfide oxidation method. Most commonly used methods are static gassing out and dynamic gassing out. The KLA is a very useful parameter to characterize the bioreactor capacity for aeration, meaning that the ability and capacity of the reactor in terms of the mass transfer rate. This helps the reactor design, optimization of technologies, and scaling up or scaling down the process. In this technique, we shall employ a common equation used. By integrating the equation, we'll obtain the following expression, which is ln C star minus CL equals to minus KLAT. Let's start with the static gassing out method. The static gassing out method, meaning that it is a method in the absence of microbes. In this method, the oxygen concentration of the solution is lower by gassing out with liquid N2. The deoxygenated liquid is then aerated, agitated, and increase in dissolved oxygen is monitored with oxygen probe. When you have the data of the dissolved oxygen, the current recorded value of dissolved oxygen in the fermenter, which is referring to Cl, then what you have to do is the C star value, the saturation dissolved oxygen in water at that particular temperature and pressure, okay, minus with the current or the recorded or the measured value of the saturation dissolved oxygen in the fermenter, and ln the value, each of the value, and then the values are used to plot a graph of ln C star minus CL over T, whether T is in time or second. Okay, depends on the number of the data recorded. Then it will give you a straight line, okay, a negative straight line, linear line, okay, with a slope of negative KLA. Then the slope of the line is the value of the KLA. The C star value, you can refer to the table of dissolved oxygen at different temperature and pressure, because it depends on the temperature of the fermentation. Another method is by using the dynamic gassing out method. This dynamic gassing out method is a method where in the fermenter there is a presence of microbes. At time T node, okay, turn off air supply to the vessel and monitor and record reduction of dissolved oxygen between T node and T1. At T1, turn the air supply on again and then monitor and record the rise of dissolved oxygen. Just now, for the static gassing out method, we just record the concentration of dissolved oxygen transfer in the fermenter. But for this dynamic gassing out method, we record the oxygen transfer as well as the oxygen uptake. So for the respiring system, which is the system which have the microbes, microbes fermentation, the dCl over dt is equivalent to KLA times C star minus Cl, minus QO2x. KLA C star minus Cl is referring to oxygen transfer rate. QO2x is referring to the oxygen uptake rate. Let's see the schematic diagram here. Point A shows the level of DO before it was consumed, meaning that air supply is off. Therefore, at this rate, the dCl over dt is equivalent to OUR when the value is dropping up until the point B. Point B represents the aeration is resumed into the culture and the dissolved oxygen concentration increases as a function of time. So QO2 is the slope between A and B. This B value, it should be for the dynamic gassing out because we're having microbes inside the fermentation. So it should be at the level of the critical, the C critical value, meaning that about 10% of oxygen. Then you have to, on the air supply, on the air supply, what happened? It will increase up until point C, where it represents steady state value. And over period B and C, there will be increment in terms of dissolved oxygen. And this difference between B and C, it is expressed by dCl over dt equals to OTR minus OUR. Because within this B and C point, there is an uptake and there is a transfer. Because we are supplying the oxygen, but due to the fermentation have these microbes, there is also an uptake. Ascending curve of B and C can be used in order to calculate the KLA. Values of dCl over dt can be estimated from the slope of the ascending curve at various time points. So each of the points available between B and C, here we have to determine the slope. The slope of each of the points referring to dCl over dt. Right, in order for us to calculate the KLA.